So today we're going to review how to simplify radicals, as well as learn a new method that we will need to simplify radicals of different index. So the square root has an index of 2. If it were a square root, if it had an index of 1, it would mean you weren't doing a square root. So what a square root means, or a radical with a root 2 means, is what number do you need to multiply by itself twice in order to get the value inside of the radical. So in other words, in this case, what number would we have to multiply by itself twice to get 16? The answer is 4. The reason for that is 4 times 4 is equal to 16. Now, this is radical 32. What number do we have to multiply by itself twice to get radical 32? Well, it has to be some decimal, because 4 times 4 is 16, and, well, 5 times 5 is 25, and 6 times 6 is 36. So it has to be somewhere between 5 and 6. So this doesn't have a nice round number, meaning it's the square root of 32 is actually a irrational number. So it is a non-terminating, non-repeating decimal. Now, we can still do what's called simplifying a radical, which means to factor out all of the perfect square factors of radical 32. Now, the way we're going to do that is we're just going to make a list of numbers that go into 32. So 1 and 32, 2 and 16, 4 and 8, and I believe that is all of them. And we're going to look for the largest perfect square among them. So among this list here, we have 16 and 4 and 1 as perfect squares. 1 is always going to be a perfect square factor and never accomplishes anything when simplifying a radical. 4 is smaller than 16, so if we did use 4, we'd actually have to simplify again. So we're going to be using 16. So we are going to get radical 16 and radical 2. So that's just the 2 and 16 unmultiplied together into two separate radicals. Now we can simplify radical 16. Radical 16, as we said a moment ago, is 4. Now this is not going to be the method that we are going to be using to simplify radicals in the future. So let me demonstrate another method. So for other indexes, we're actually going to need to find the prime factorization of numbers. So for 32, for instance, the prime factorization would mean to separate 32 into all of its factors. So 32 is equal to 2 times 16. 16 will be equal to 2 times 8. And as these branches reach prime numbers, we will circle them. 8 will be equal to 2 times 4. And 4 will be equal to 2 times 2. So the prime factorization of 32 is 2 to the 5th power. So 32 can be rewritten as 2 to the 5th power. Now, a different number might have different factors, and it would be written a little differently. Now, because the index of a square root is 2, we're going to separate 2 to the 5th into groups of 2's, in this case, that are are divisible by 2. So 5 is not divisible by 2, so we're going to rewrite this as 2 to the 4th power times 2 to the 1st power. It's still 2 to the 5th power. This still equals 32. This still equals 32 as well. And we're just going to take the square root of the values inside of the square root. So what number multiplies by itself to equal 2 to the 4th power? Well, 2 to the 2nd power, pretty much meaning we take the exponent on the inside and divide it by the index on the outside. So 2 to the 4th will become 2 to the 2nd, and the 2 to the 1st will stay inside because the 1 is not divisible by 2. So because 1 is not divisible by 2, it stays inside of the radical. Because the 4 was divisible by 2, it comes out and gets divided. So our final answer would be 4 radical 2. This might seem like more work, but it will be more necessary for other indexes. Let's take a look at this example here, negative 500. So we're going to take the prime factorization of 500. So that will be 2 times 250, which will then separate into 2 times 125, which will then separate into 5 times 25, which will then separate into 5 times 5. So firstly, we'll take out the I from the negative. If the index is even, in this case the index is 2, there will be an I in our answer. If it is odd, our answer will have a negative coefficient. We'll get into that when we get to the odd indexes. So this can be rewritten as 2 to the second, 5 to the third. And like I mentioned before, we're going to rewrite this so that the exponents are have at least some even component. So this will be equal to I, radical 2 to the second, 5 to the second, and 5 to the first. So the 2 to the second square root is going to be 2 to the first. So we're going to get 2. The 5 to the second square root is going to be 5 to the first, so 5. We still have an I out here. So these have now come out of the radical, and the 5 to the first power is going to stay inside. So this will simplify to be 10I radical 5. X to the fourth is even easier. It's already in its prime factored form. X to the fourth is just x times x times x times x. So what is the square root of x to the fourth? Well, we use the same rule we did a moment ago. We look at our index and we take our x to the fourth, or exponent, and we divide it by the index, and we get x to the second. If we look at our next example, we're going to take the prime factorization of 72. So 72 will become 2 times 36. 36 will become 2 times 18. 18 will become 2 times 9. 9 will become 3 times 3. So this will simplify to be 2 to the second and times 2 to the first. I'm purposely grouping them in even amounts because my index is 2. And we have an x to the sixth. Oh wait, excuse me. Times 3 to the second and an x to the sixth. Anything with an even exponent will come out and get divided by 2 because that is the index. So 2 to the second will come out as a 2. 3 to the second will come out as a 3 to the first. The x to the sixth will come out as an x to the third. And we still have inside the 2 to the first because it wasn't divisible by 2. So our final answer will be 6x to the third, square root of 2. Let's look at a more complicated example. In this example, we also have a leading coefficient. It's not going to factor into the problem, it's just going to stay outside. The 40 will become 2 times 20, 2 times 10, and 2 times 5. So this is 2 to the second times 2 to the first times 5 to the first, x to the fourth, y to the sixth. So once again, we have the 2 that's already out here. When we take the square root of 2 to the second, it comes out as 2 to the first. When we take the square root of x to the fourth, it comes out as x to the second. When we take the square root of y to the sixth, it comes out as y to the third. And we are left with a 2 and a 5 inside of the radical. We're just going to simplify the outside and then simplify the inside. So the outside will be 2 times 2, which is 4, x to the second, y to the third, and on the inside we will have 10. We'll do the same thing for the next example. We'll bring out the I to start the problem. 15 is 3 times 5, and we have x to the sixth and y to the second and y to the first. In this case, the exponent of the variable was not divisible by 2. Again, our index is 2. So we're just going to do the same thing we did a moment ago. 3i. The x to the sixth will come out as x to the third. The y to the second will come out as y. And everything else will stay inside of the radical because they did not have an exponent that was divisible by the index. So the final answer here is 3 x to the third y I radical 15y. Now, the I is not really a variable, so it doesn't really matter where it goes. Usually it goes at the end of the string of variables. So let's use this process with a different index. All of these problems can be done using an index of 3. So let's take a look at how that would look. Well, in this case, if we had a cubic root, meaning what number is required to multiply by itself 3 times to give us a 16, we would apply this process a little differently. Well, 16 is equal to 2 to the 4th power, so I'm going to rewrite that as 2 to the 3rd and 2 to the 1st. And because the index is a 3, we will be dividing the exponents by 3's to take things out. So the 2 to the 3rd comes out as a 2 to the 1st. So this is the final answer for that example, is just 2 radical 2. For radical cubic root of 32, 32 becomes the cubic root of 2 to the 3rd times 2 to the 2nd. The 2 to the 3rd will come out as a 2, and we'll be left with a 4. Because 2 squared is 4. 4 doesn't have a cubic root, so it's stuck inside of our radical. In example 3, the negative is actually just going to come out as a negative. And the reason for that is that negative 1 to the 3rd is technically a factor of 500. And no matter what index this is, if it was a 9, we could have said that negative 1 to the 9th was a factor. So with an odd index, you can factor out a negative. So negative 1 will be on the outside here. We'll look at the factored form of 500. We'll just look back at what we wrote before. It was 2 to the 2nd and 5 to the 3rd. So 2 to the 2nd and 5 to the 3rd. The 5 to the 3rd can come out as a 5, so this will become negative 5, cubic root of 4. Same thing happens with the variables. This would become the cubic root of x to the 3rd times x to the 1st. The x to the 3rd will come out as an x, and we get the cubic root of x times x. Well, x times the cubic root of x. And that's because the x to the 1st could not come out because it didn't have enough copies of itself. Radical 72, let's just take a quick reminder of what the factored form of radical 72 was. It was 1, 2, 3 2's and 2 3's. So the 2 is going to come out. The 3 to the 3rd isn't. The 3 to the 2nd is not, because 2 is not divisible by 3. And the x to the 6th will come out as x squared. So 3 to the 2nd will become a 9. The 2 in this case is a coefficient. It will just stay at the front of the example. So we don't need to worry about that for now. We don't have any negatives to take out either. We're going to factor 40 into, so that is 2 to the 3rd, which is 8 times 5, x to the 3rd, x to the 1st, because the 4 is not divisible by 3. Y to the 6th is divisible by 3, so we'll leave it together. So we get 2 times x times y to the 2nd, and we are still left with a 5x inside of the radical. So our final answer will be 4x y to the 2nd cubic root of 5x. Don't make a mistake and misread the index as a exponent. And we have one more question to do. And that is here. Same problem from before. We have a 3. We have the cubic root of the 15, which is just a 3 and a 5. Oh, the negative comes out in this case because we have an odd index. X to the 6th is divisible by 3, and y to the 3rd is also divisible by 3. So our final answer should be negative 3, x to the 2nd, y to the 1st, and the cubic root of 15. And you could apply this to any index. So if the index was a 4, we would be separating things into groups of 4, and so on. Let's take a quick look at multiplication and how that works with radicals, and that'll be the end of this video. Oh, addition, then multiplication, really quickly. You treat radicals like variables, so if this was really x plus y, you can't combine them because they're unlike terms. So you need to have like radicands to do that. That also applies to the index. So these are clearly unlike terms. This is like an x and a y, but you still wouldn't be able to combine them if we had a cubic root of 2 and a fifth root of 2. You can't add these. These are all unlike terms. This is like an x and this is like a y. So you can't combine unlike terms. Now this one, on the other hand, if you were to simplify this, you would get 2 to the fourth times 2 to the first, or 4 radical 2, plus radical 2. These are now like terms. We have 1 copy of radical 2 and 4 copies of radical 2. This would be 5 radical 2. So you can add these if they have the same radicand with the same index. And same thing applies for subtraction. So let's simplify this one to see if it simplifies. I get 3 radical 2, and these are unlike radicands. We have a radicand of 6 and a radicand of 2, so this one cannot be combined any further. So the only one here that was combinable was radical 2 and radical 32, and that was after simplifying. So for addition, you're going to want to simplify at the beginning of the problem. And briefly, we'll talk about multiplication. The rules for multiplying radicals is that they have to have the same index. So if this was a cubic root and the other one was a square root, or let's say a 7th root, just for an example, we could not multiply these the way they're currently written. We'd have to use another process for doing that. We'll talk about that in the future, but the basic idea for multiplying radicands that have the same index is you multiply the coefficients, so that would become negative 18x, and you multiply the contents of the radicands. So we would get radical 80x to the third, in which case we can then simplify these completely to get our final answer. So we'll do that really quickly. So we get negative 18x, and this is going to be the square root of, we have to simplify this, but this will be x squared and x because we have an index of 2. 80 is going to be equal to 2 times 40. 40 is going to be equal to 2 times 20, and 2 times 10, and 2 times 5, which is a prime number. So that's going to be 2 to the fourth, 5. So this will come out as 2 to the second, which is going to be 4. The x squared is going to come out as an x. So we have the x that was already out here, then the x from inside the radicand, and still inside the radicand would be a 5x. So the final answer would be negative 72 x squared radical 5x. All right, good luck on our lesson tomorrow. If you have any questions, start the class with them.